Welcome to Study Loop.
Okay, so for this question, we need to determine the Mach number first, which is equal to V over C, which is equal to V over square root KRT. So we know the specific heat ratio for the carbon dioxide is equal to 1.289, and the gas constant for the carbon dioxide is 0.1889 kilojoule per kilogram times Kelvin. And we know the given temperature is 310 degrees Celsius. If we convert to Kelvin, it's about 583 Kelvin. And we know the velocity is given as 16 meters per second. So if you plug in that equation, eventually you have the Mach number is about 0.159. So now we can determine the stagnation temperature. So stagnation temperature, which is T0 here, over T is equal to 1 plus K minus 1 over 2 times MA squared. So if we do some arrangement here, we'll have the T0 is equal to T times 1 plus K minus 1 over 2 times MA squared. So now let's plug in the values. So eventually we'll have stagnation temperature T0 is equal to 585.13 Kelvin. So now we can determine the critical temperature, which is the temperature at the throats. So we have T asterisk is equal to 2T0 over K plus 1. So now we can plug in the values. We can use the 2T0 over K plus 1 substitute for the T asterisk, since we know the critical velocity is equal to square root KRT asterisk, which is the velocity of carbon dioxide at the throats, the one we are looking for to determine. Okay. So this is equal to square root KR times 2T0 over K plus 1. So now we know the specific heat ratio for the carbon dioxide is 1.289, and we know gas constant, and we also know that T0 is equal to 585.13 Kelvin. So now let's plug in back to the equation to determine the velocity of carbon dioxide at the throats, which is equal to square root 1.289 times 0.1889 kilojoule per kilogram times Kelvin, and then times 2 times 585.13 Kelvin over 1.289 plus 1. And always never forget to convert it to meter square per second square. Okay, so we need to multiply 1,000 meters square per second square, and then over 1 kilojoule per kilogram. Or another way to do it, you can just simply times 1,000 and convert kilojoule to joule. Okay, so this will give us the velocity of the carbon dioxide at the throats, which is the critical velocity, is about 353 meter per second. So now let's take a look at the choices. So the correct answer should be D.